Hello again, dear students. Here's the second section in your first chapter. It's talking about playing with the function. When I say playing or manipulating, I mean combining, shifting, scaling of the graph. That means that the shifting and scaling is that the multiplication. First of all, in this chapter, in this section, example 1, we are going to talk about the domain of the function, of two functions. In case if we add or we subtract or we subtract again, or we multiply, or we divide. So in that case, what will happen to our domain? We are not going to talk about the range because the range will totally change, and there are sometimes, for example, like that. For example, we need more thinking, and sometimes we need a calculator. So that's why our focus will be on the domain. The domain in this function, for example, f of x, f is equal to square root of x, and the second function is g of x is equal to square root of 1 minus x. The books say that if you have domain of the f and d of g, means that find the domain of the function f and g. Then for f plus g, just find the domain, say the domain is equal f intersection domain of g. Okay, the books say that. For example, the domain of f is equal to what? As you know, d of f is equal to 0 to infinity. Am I right? How about the other domain of g? D of g is equal to minus infinity to 1, like the previous example, to 1, close 1. Okay, now I'm going to add this function. I say f plus g was equal to square root of x plus square root of 1 minus x. If I asked you about the domain, just directly say is equal to this one, intersect that one, and give me the result. What do you mean by the intersect? First, show me the 0, the first one, to infinity. Okay, how about the second? I'll do it by the black one. Here's 1, okay, going to minus infinity. Where's the intersection? You can see here's the intersection. So the intersection is equal to 0, 1. That's why we say the domain of f plus g is equal to this part. That's all about the. How about negation or subtraction? How about the other subtraction? How about f dot g? They are the same. All are equal to 0 and 1. Why? Because it's equal to domain f intersection domain g. That's why. There's a special case in the division when we say f divide by g, means that f over g division. So in that case we have f and also we have g. So in that case we say is equal to f intersection g. But there's one exception, one notification is what? To not let the domain of g to be equal to 0. Do not let or exclude those values that make our domain, make our denominator. Here's numerator, here's denominator. We will exclude those values that make our denominator to be 0. So in that case we have what? We have 0 and 1. Before we did it, right? Here's your d circle g. But there's a notification, as I told you, there's an exclusion. So in that exclusion, we say what? We will exceed number 1. Why? Because if I put 1, I will get what? I will get 0. That's why we will change it to this. So this is df dg. Okay? Or you can say df by g. That's all. I think it's easy, it's not. If you are not understand, now try to understand g divide by f was equal to g divide the numerator, there's numerator, this is denominator. We say that df intersection dg, we will say that domain of g over f is equal d, for example, f intersection dg, but we have an excluding some value. So d is equal to what? That's it. So how about which value in here will make our denominator to be 0? Surely 0. That's why we will exclude 0 and we will include 1. That's the answer. Okay, dear? That's all why we have. And now we have a composition of function in page number 1. In the second section, page number 1, in the second section, we have what? Composition of function. What do you mean by composition of function? Sometimes we say f circle g. Okay, and how we solve this one? It's very easy. Just follow my instruction. You will find it's easy. For example, if you have, now I'm going to explain this by the example, as we have example 2 in page 2, section 2. Now, if you have f of x is equal to square root of x and g of x is equal to x plus 1. Now find what? Find the f. We have 4 cases, for example, f circle g, or g circle f, or f circle f, g circle g. Now in that case, just do like that, okay? Say we have f and closed g of x. Write down the g in the closed box, okay? It's x plus 1. So input, this one you have a. If I put x, I will get square root of x. If I put a, I will get square root of a. How about if I put x plus 1? I will get anything here. We will put the square root. That's all. Now I'm going to solve the second one. G circle f of x is equal to g. I'll put the box. F of x. And I'm going to write down the box as we have without any change. But now, if I give x, I will get x plus 1. If I get 49, I will get 50. 49 plus 1. If I put square root of x, I will get what? Square root plus 1. So that's why I say is equal to square root plus 1. That's all that we need. How about g circle g or f circle f? Number 3. F circle f, we will say is equal to f box f, and which is equal to f square root of x. Now, if I put f of x is equal to square root, if I put square root, I will get square root of x. Okay, so it's equal to fourth root of x. Now the fourth time, g circle g of x, we will say g closed box x. Now I have what? X plus 1. If I give anything to x, x will give me x plus 1. How about if I give, I told you if I give 1, it will give me 2. If I put 2, I'll get what? I'll get 3. That's all that you need. Okay. And there's a notes about the function after this example. After example 2. There's a notification here, and I will left this as a homework for you. Please think about it. It's very important. Now, how about shifting the graph? And yes, about the shift. When I say shift, means that forward or going to up, or what? Or going to down. Okay. Going to down. So when we have a vertical x addition, means that I will give you f of x. Now if I say f of x plus number, something plus number, so I'm going to up. Look, when I say outside, here's the outside. For example, f of x is equal to x squared. Now my function will change it to x squared plus 2. I mean by that. So this is outside and we'll go into up. If it's positive, if it's a negative, we'll go into down. What do you mean by up and down? I know f of x is equal to x squared. Is like that. How about if I say f of x is equal to x squared plus 1? So I'm going up by 1. So shifting to up. Shift. Why? Because number outside. How about shift? Sorry. How about f of x is equal to x squared minus 5. I see this is x squared, 1 2 3 4 5 minus, so this is minus 5. Okay dear, that's all you need. How about if the second part, shifting to right and left? If I add our function, now I'm going to add a number inside the function, or subtracting inside the function. What do you mean by that? For example, f of x is equal to x squared, then f of x is equal to, look, there's a difference between here and there, x plus, for example, 2 square or minus 2 square. What will happen here? So let me minus first. If it's a minus, means that go to the right. If it's a negative, means that go to the, if it's a negative, go to the right. If it's positive, go to the left. What do you mean? So here's my x square. Now this is my 1 2. I'm going to start from 2. Y is equal to x minus 2 square. What changed? Nothing. The shapes are the same, just we shifted. Okay, right to left. Now how about y is equal to x plus 3 square? So here's x square. Okay, here's 1 2 3 because they're positive. So like that, dear. Sorry, like that. And go on. Okay dear, that's y is equal to x plus 3 square. And you can see all these details here. Really, there's another example. Now we have also multiplying. We are called as a stretch and compress by multiplying by number or by half number. For example, 2f of x. For example, I say y is equal to, for this part, cfx. What do you mean by this one? You see stretch. We have what? We have, for example, y is equal to 2x squared. At least see 3x squared. So they are the same shape, but a little bit changed to the stretching to here, like that. Okay, how compressing like that? Or for example, if I have 1 over 3x squared, so the shape are still same, but a little bit wide or stretching or compressing. So don't really this, I don't care about this part. How about this one? Is very important because we'll give you the reflexing. So for the reflexing is very important. For getting the reflexing, you have two cases. Reflex. Okay, maybe outside the function, maybe inside the function. What do you mean by outside the function? For example, if f of x is equal to x squared. Look, in that case, I think, yes. In that case, let my function be square root of x. If f of x is equal to minus square root of x, what will happen? This is my original one. So how about this? So minus x squared means that we will multiply outside. So the x-axis will be your mirror. So this x-axis mirror. When I say mirror, here's the mirror, like that. So this is the graph of what? Minus x, if it's outside. How about if it's x minus is include or inside your function? Means that y-axis is your mirror. What means that here's your function. So if I have f of x or y is equal to square, so this is the original one, right? So y-axis will be what? Will be my mirror. So this is the function. Y is equal to square root of minus x. So square root of x. Square root of x. That's all. So in that case, we have this one. Now I am going to play with it. F of x is equal to minus of x. What happened? I'm going to what? I see this is my original. Okay. Now multiplied by inside means that I have this one, and multiplied by minus, so means that I have that one. This is the last graph. Okay dear, that's all I need to give you in the page number 3. For page number 4, there is nothing to be worried. Just example 4, sorry, there is nothing, just mentioning about the planar graph. we will finish here, and don't forget about the example number 5. We are finishing this section, and so see you in the next section, section 3. And please do not forget to play with the function. Just write down, for example, y is equal to x squared. Now this time it's time to multiply by negative. This time is to play with something else to do it. For example, try to also use y is equal cubic, and now multiply by minus inside, anything that you need to do it. So see what will happen. Please do not forget to try your best and try to study very well. If you have a question, I will give you the time, and I am going to arrange a meeting as soon as possible. Thank you for watching. See you. Bye.